Welcome to my YouTube channel. Today I am going to discuss about the topic is data structure overview and stack. So this particular topic belongs to the subject name C programming and data structure. So this is a unit number 3 syllabus. Under the unit number 3, I am going to discuss first what is the data structure, then overview, then stack data structure representation, stack related terminologies, operation on the stack implementation. This is what I am going to discuss in this video today. First of all, data structure. So the real-time example, the internal operation of the data structure, the real-time example, you can compare both the diagram. In your left-hand side, there is a shop which is kept the item in well organized. You can see in your right-hand side, the items in the shops are not well organized. So if you want to pick up any item, you can easily pick up from your left-hand side shop item. This one, you can see there is an oil can. There is a separate number of things are available. While we are going to be watching these entire items, you can able to understand how to pick and where it is available, everything. But you are going to be seeing this side, it is very clumsy and unorganized way. They kept all the items inside the shop. Okay, so regarding the data structure, we are going to be taking all the data and arranging inside the memory. That is called as the data structure. Now we can see the definition of data structure. Data structure is a specialized format for organizing. So data we are taking and kept it in the memory. That particular keeping the data items inside the memory, that should be properly organized. Comma, processing, comma, retrieving and storing the data in the memory. Regarding the retrieve, we are going to be reading our required information from the memory. That is called as the retrieve. And storing, whatever we are going to be store the information, we are going to store it into the memory. Okay, so initially we are going to be retrieving whatever the data required, we are going to be searching in the memory and we are going to be retrieving the required data from the memory. Then we are going to be applying operation on the data. That means processing. If C equal to A plus B, A value, B value available in the memory, we are going to be reading. That is the retrieving. After retrieving, we are going to be adding the A plus B. Then we are going to be storing the resultant into the C. That C we are going to be store it in the database. That C result or that C we are going to be store it in the database. Regarding this A plus B, that is called as the addition or processing. So I'll repeat the definition, listen properly. Data structure is a specialized format for organizing the data in the memory. Then we can able to do the data processing, data retrieving and storing the data in the physical memory. So this is called as the data structure. Then types of data structure. Number 1 is the linear, number 2 is the non-linear. Linear means simply we can say sequential access one after another in a sequential way. If you are going to be accessing the data, that is called as the linear data structure. The opposite way called as the non-linear data structure. If you want to store or read that particular information in a random way, you can able to understand from the example. If you are going to be store the alphabetic from A to Z, 26 letters in the memory, with the help of linear data structure, it is going to be storing A, B, C, D, E, F in the same sequence. Okay, in the non-linear data structure, we are storing in the alphabetic same order only. If you want to access the D, directly you can able to access the D in the non-linear. In case of linear, we need to be access first A, then B, then C, then D. So we are going to be doing the operation in a sequential way. Even if you want the 4th data or 10th data or 8th data, whatever it may be, we are going to be accessing the data one after another. Then types of data structure example. So linear data structure, non-linear data structure. Regarding the linear data structure, array is there. Stack, queue, linked list. Stack and queue we are going to discuss under the unit number 3. Linked list we are going to discuss under the unit number 4. Non-linear data structure example, tree, graph, table and set. So these things we are going to discuss under the unit number 5. This is an example of non-linear and linear data structure. Next, stack, content. First one, definition, then stack, data structure or representation. Next, terminologies. Next, example, program, application of a stack. We can see the definition. It is one of the most important linear data structure and it is working based on the principle of last in first out, LIFO. The meaning of the last in first out means, I will explain based on the diagram. Initially I inserted, this is a stack data structure. Initially I inserted the A, then B, then C. This is the way I inserted all the 3 elements. If you want to delete, we need to delete first C because it is the last input element. Because it is the last input element. So first I need to delete the C, second I need to delete the B, third I need to delete the A. So in this way I need to do the deleting. So this is called as the last in first out. Insertion in a B, C order, deleting in a C, B, A order. Okay, so this is called as the last in first out principle. If you want to insert the element or if you want to delete the element, we can able to do the process with the help of top only. The top indicating the value of the location. So according to the stack data structure, 1, 2, 3, 4. Size is called as the 4. We can able to store 4 element. That's why I am saying size equal to 4. It is locating the second location. That means location number second. But the data third. The representation started from the 0, 1, 2, 3. The location address. But data wise it is the third data. Location address wise it is the second one. So top equal to 2. So this is the stack data structure. Next, list of terminologies. Number 1, top. Number 2, overflow. Number 3, underflow. Number 4, push operation. Number 5, pop operation. Number 6, display. Regarding the top, it is the pointer. In the previous diagram we saw top is the pointer. With the help of top pointer we can able to do the insertion and deletion. Then apart from this, the top is always keep tracking of the top of the element in the stack. Overflow. Whenever the stack is getting full, that is the condition called as the overflow condition. Whenever the stack is getting empty, that is the condition called as the underflow. Push means insertion operation. Pop, deleting operation. Display means whatever the element available in the stack that should be displaying in the output. So this is a list of terminology. Next, first terminology, top. It is the pointer to keep track of the top of the element in the stack. You can able to see top indicating the B. B is the top of the element in the stack. The top contain the location address of 1. The stack size is 4. Okay, so this particular information highlighted in the red point. Top indicating the top of the element in the stack and top value is 1. Top indicating the address of 1. Okay, then if you want to, it is used to insert the element, the function called as the push. Delete the element with the help of top pointer, we can able to do the deletion of the element, the operation called as the pop. Then and verifying the current position, whether the top is indicating the address of 1 or 0 or -1 or 3. Okay, so whatever it may be, it is indicating through this one we can able to check the stack is full or stack is empty. That is what they are saying, underflow and overflow condition. Next terminology, push operation. Okay, so it is the operation to insert the element into the stack. Okay, if you want to insert the element into the stack, there is supposed to be some empty space. The size is 4. It contains 4 elements. So it is already full. So we can't able to insert the element inside the stack. Okay, so that is we are checking through the coding. Top indicating the address of 3. So there is a coding. If condition top equal to size minus 1. What is the size of the stack? 4. 4 minus 1, 3. 3 equal to 3. Then condition is true. Then we are going to be executing the body of the if condition. Body of the if condition is single line. Printf, stack is full, not possible to insert. That is the coding. So push is the operation. Before doing the push operation, we need to be check whether the stack is in the overflow condition or not. Okay, for that one there is a condition in the if condition, top equal to size minus n. According to this particular data structure, it is correct. Top value is 3, size minus 1 is 3. So 3 equal to 3. It is condition is true. Then body of the if condition, printf, stack is full, not possible to insert. Okay, the same calculation I written here. You can see in the highlighted color of red. Okay, size equal to 4, size minus 1 3, top equal to 3. So 3 equal to 3, condition true, stack is full. Okay, suppose in this particular data structure, is there any empty space? Or maybe one empty space or two empty space. Okay, so whatever it may be, is there any empty space? Then automatically size minus 1 is 3, but top value is not 3. If it is 1 empty, the top is indicating 2. If there is 2 empty, top is indicating 1. If there is a 3 empty, top is indicating 0. If it is the purely empty for all the 4 locations, then the top indicating the minus 1. So whatever may be 2, 1, 0, minus 1, these 4 numbers condition is getting failed. If the if condition getting failed, then automatically it is going for else body. You can see the else body in the next slide. Else body is there. For executing the else body, there is another data structure I drawn with one empty. We can able to insert one element here. Okay, so according to this particular data structure, we are going to be checking the if condition. Top indicating 2, size minus 1 3. So 2 equal to 3, both are not equal. So automatically if condition is getting failed. Now we are going for else condition. So first line, top plus plus. That means we are incrementing the top from 2 to 3. It is moving from here to there. The reason, if you are incrementing or if you are moving the next empty location, then we can able to insert the element inside the data structure. Inside the data structure in the empty space. You can see the highlightation. So top plus plus indicated in the red. Then top indicated in the red. The top location, top equal to 3. Now we incremented the top and it is indicating the next empty location to getting the input element. Into the stack. Okay, so now we want to put a element into the stack. You can see the next line, stack of top equal to value. If you are executing the second line, the value is entered inside the data structure. You can see in the next one, stack of top equal to value. So the D is entered here. Okay, once we inserted successfully, then we need to give the message that insertion is successful. That is what the next line. Printf, insertion is successful. Next, pop operation. Pop means it is the operation to delete or remove the element from the stack. Okay, if you want to delete, you are going to be checking the stack whether there is any even single element or not. If there is a single element, we can able to delete, or more than one element also we can able to delete it. If it is empty, we can't able to perform the delete operation. We can't able to perform the delete operation. So that is called as the underflow condition. That is called as the underflow condition. So this particular data structure I drawn with the condition of underflow, the top is indicating the -1, so that means underflow. So this is what I written in the coding. If top equal to -1, printf stack is empty. Not possible to do the deleting. Not possible to do the deleting. That means the top not supposed to be indicating the -1. Then we can able to perform the deleting operation. That means top supposed to be 0 or 1 or 2 or 3, any locations. Okay, so based on the non-1 values in the top, then automatically we can able to perform the deleting operation. That means this particular if condition is getting fail. Particular if condition is getting fail. Then automatically it is going for else body. It is going for else body. Okay, so that what if condition highlighted, if condition is true means that is the underflow condition, stack is empty. Underflow condition, stack is empty. If the if condition is getting failed, then we are going for else body. In the else body inside first line is we are going to be printing the stack value. We are going to be printing the stack value. Printf delete %d stack of top. %d stack of top. Once we are going to be executing this particular line, then automatically this particular B is transferred into your output. You can see now it is transferred into the output after deleting. Second line is the top minus top minus. Okay, the meaning of the top or definition of the top is the pointer. Always keep tracking of the top of the element in the stack. Okay, so after deleting it is locating the empty location. That's why we are decrement the top pointer into the A. Because A is the right now top of the element in the stack. So that's why we are decrementing the second line top minus, then top is getting down and indicating the A value. Okay, so according to the movement, I changed the address of the top or a value of the top. Top equal right now 0. Okay, then display. In operation of pop and in operation of display, we need to be check the underflow condition. Both functions or both operations, we need to check the underflow condition. The reason, if there is no element, we can't able to perform the display operation. If there is no element, we can't able to do the deleting operation. So there should be compulsory some element inside the stack. So that's why initially if condition is there, top equal to -1, printf stack is empty, not possible to display. Suppose is there any element? Then top is locating non-1. It is not supposed to be indicating the -1. If there is any element, maybe one element means 0 indication, 2 element means 1 indication, there is a 3 element 2 indication, 4 element top will be indicating the 3. Okay, so if it is not empty, the top should not be indicate the -1. Okay, so like that kind of example, if condition is getting failed, then automatically it is moving to the else body. According to the else body, we are declaring the first variable. Integer I. This particular variable is used for loop variable. Integer I. Printf stack elements are. You can look in the output. Simply we are displaying the D, C, B, A means it is not look like perfect. So before the element, we are simply writing one text stack element R. That is the second line. Stack element R. Simply we are printing output that the following elements are stack elements. Okay, then for loop is there. If you want to display the element, okay, we need to be display from top to 0 as per the last in first out. So we entered first A, second B, third C, fourth D. If you want to delete D, C, B, A in a reverse order, we need to be delete perform the delete operation. Similarly, if you want to display in a reverse order only, we need to be display based on the principle of stack is last in first out. Based on the principle of stack is last in first out. Okay, so initially we are assigning top into the initial value. Top is 3, I equal to 3. Then condition, we are going to be displaying from the 3 to 0. 3 to 0. So that's why the condition is I is greater than or equal to 0. I is greater than or equal to 0. Okay, so initially we are giving the top value into the I, that is the 3. Then we are giving the condition up to 0. Up to 0. From the 3 up to 0. That is what we gave the condition. From 3, the second element 2, the third element 1, then the fourth element 0. So between the element there is a minus 1. So that's why I used here decrement operator, I minus minus. Okay, so overall this particular for loop will generate the number from 3, starting 3, then 2, then 2, then 1, then 0. Okay, so 3, 2, 1, 0. So this is the way the for loop is going to be generating the value of the I. Generating the value of I. So initially top equal to 3 na, condition is true. The body of the for loop is single line printf statement. Single line printf statement. So printf %d slash n stack of I. Slash n stack of I. So now it is printing the D. Now it is printing the D. After printing the first element, then the decrement operator is going to be executed. Okay, so initially it is 3. Now after decrementing 2. After decrementing 2. Now also condition true. Now also condition true. The body of the for loop is executed printf. C is printed in your output. Again, we are going to be decrementing one more time. And again checking the condition. Now after decrementing, the I value is 1. I value is 1. Okay, our condition is true. We are printing the B. Again, we are going to be decrementing the pointer. Now the pointer is 0. I is 0 after decrementing. Then condition is true. Then we are displaying the A. We are displaying the A in the output. Okay, after condition true, displaying the A, again decrementing. So minus 1. Minus 1 is not greater than 0 and not equal to 0. So automatically this particular condition is getting failed. Then looping is getting stopped. Okay, after execution of this entire function, we got the output like this: DCBA. That is the displaying the element from the stack into the output. Okay, so you can see the program, C program implementation of the stack using the array. So initially there is yesterday.h, conio.h, two header files are there. The third line is there. We are assigning the default value, or we are going to be defining the default value of the size 10. Then after there is a 3 line void push integer, void pop, void display. If you want to insert operation, we need to be give the value to be insert. That's why they are written here integer. Void pop, void. So regarding the deleting, as per the last in first out, it is going to be deleting automatically. The top of the element in the stack. So that's why no argument. Void pop, void. Similarly, void display, void also. We are going to be displaying the element from the stack into the output. So there is no argument. For pop and argument for the display, and also no return value for push pop display. Okay, so these 3 lines are called as the function declaration or function prototype. Okay, the next line, integer stack of size. Then top equal to minus 1. Stack of size is called as the array declaration. The array created with the size of 10. Similarly, top equal to -1 means initially created stack is empty. That initial value of the empty stack for the top is -1. Initial value of the top for the empty stack is -1. For the empty stack is -1. Then void main, integer value choice. We are having the operation of push, pop, display and then exit. For among the 4 operations, we are going to be selecting the choice based on the choice variable. Then value. If you want to do the push operation, we need to be provide the element to push into the stack. So for that one value, okay, selecting the operation choice is there through the switch case, okay. So this particular integer stack top equal to -1 also declaration, variable declaration. Integer value comma choice also variable declaration. The difference between this declaration and this declaration is, this one is global declaration. It can able to access the entire program. This can able to access the entire program. Stack and top, both variables are accessed in the entire program. But value choice, it is declared inside the main. So it is going to be accessed within the main only. So integer value comma choice is accessed inside the main function. So it is called as the local declaration and it is called as the global declaration. Then clear screen. Clear screen is supported by the conio.h. Clear screen gets ch supported by the conio.h. Printf, scanf, both are supported by the standard input output header file. Then while of 1. Up to now we saw under the C programming and data structure, while loop contain the condition. This is the first time we are going to be see the new thing, while of 1. So if the condition is true, that condition answer is 1. If the condition is true, the condition will generate 1. If the condition is getting fail, then the condition will generate the 0. So that means while of 1 means always condition is true. Then open bracket, printf, menu, push, 1 push, 2 pop, 3 display, 4 exit. For this particular 2 line normal printf statement, you can see the sample output in the next slide. It is going to be generating menu, push, pop, display and exit. Okay, based on this particular 2 line, 1 dot push but 2 dot pop in the next line based on the slash and variable. It means next line in the output. So this particular 2 printf output is generated like this in a blue color indication. Next, printf, enter the choice. So we need to be select the operation, maybe 1 for pushing, 2 for popping, 3 for display, 4 for exit. Okay, so if you want to enter 1, then we are going to do the scanf choice. Okay, ampersand symbol of choice. That particular one is passed through the switch case. Then automatically switch will select the case 1. Printf, enter the value to insert. Okay, enter the value to insert. That means if you want to push the element into the stack, we need to be provide the input element. So for that one, we are getting the element through the scanf. Then push value. So whenever we are going to be execute this line, or whenever the compiler reading this line, this is called as the function call. Then automatically it is moving into the function definition. You can see this is a function definition. So void push means, already I said, if you want to push the element, there supposed to be at least one empty space. That is called as the overflow condition. If top equal to size -1, stack is full, insertion is not possible. Okay, suppose there is at least one empty space, means this particular condition is getting failed. Then automatically we are going for else part. Then open bracket, body of the else part contain the first line top plus. We are going to be incrementing. Top is always indicating the top of the element in the stack. Okay, if you want to insert, we need to move the top pointer into the next empty location. For that one, we are incrementing the top pointer. After incrementing, through the top pointer, stack of top equal to value. Then we are inserting the value into the stack. Then printf. Okay, so in the printf, I am saying insertion did well. Insertion did well. Okay, that is the insertion is successful. After executing this entire user defined function of push, then it is getting back to the main function. It is getting back to the same main function of push value. Push value. After push value, there is a break is there. Break means this particular switch case is getting break. This particular switch case is getting break or getting stop. Getting stop. So switch case opened here and switch case closed here. Outside means green color. That is the while body. Inside the while body only switch case is there. Outside the switch case while body is there. Again we are checking the condition. Condition is default always true while of 1. Always true while of 1. Again the same thing is going to be getting display in the output screen. This time I am selecting the case number 2. I am entering the number 2. It is passed through the switch case and it is getting selection of case 2. So pop. Pop means this is a function call. Then automatically it is moving to the pop operation. Pop means deleting. If you want to delete in the stack, at least one element should be there. Minimum one element should be there. So we are going to be checking the underflow condition. If the stack is empty or underflow, top equal to -1. If the condition is true, stack is empty. Then we are printing stack is empty, deleting is not possible. If there is at least one element, so this particular condition is getting fail, then automatically if condition fail, then else body will execute. Else body will execute. So inside the else body, simply we are printing the top of the element in the stack. After printing or after deleting, we are supposed to be move the top pointer into the next location to indicate the top of the element. Okay, so that's why we are decrementing the top pointer. We are decrementing the top pointer. After executing the void pop, it is returned back to the same line pop. Then break is there. Now the switch case is getting break. The outside of the switch case is while body. It is true. Again printf 1 2 3 4 push pop display exit. This time I am going to be giving the input. Enter the choice. I am going to give the 3. 3 means display. 3 means display. Whenever function call executed by the compiler, then automatically it is moving to the display user defined function. User defined function. Here also similar to the pop, we are going to be checking the underflow. If it is not underflow, true condition is getting fail. Okay, it is not true, it is the false, then automatically else body is going to be execute. Else body is going to be execute. So initially I am using the integer I. This is a variable for loop variable. Printf stack elements are. Simply I am keeping the output message stack elements are. Okay, but then for loop body is only single line printf. So initially I equal to top as per the stack principle last in first out. As per the stack principle last in first out. So initially I equal to top. I equal to top. I greater than or equal to 0. I minus. So regarding this particular for loop will generate the number. Okay, so wherever suppose top is there in the location number 2. So 2, then 1, then 0. 2, 1, 0. If the stack contain 4 values, then 3, 2, 1, 0. Okay, so that is what generated by the for loop. Okay, number generated by the for loop. Based on that, stack of I is going to be changing. So initially, suppose example top indicating the 2. Top indicating the 2. So I equal to 2. I is greater than or equal to 0. I minus. Okay, so initially I equal to 2. So stack of 2 is printing. Then decrementing condition is correct. Right now I is indicating the 1. Then again the second time printing the stack of 1. Again decrementing. Now the IU value is 0. Condition is true. Next it is printing stack of 0. Okay, again it is decrementing. -1. I become -1. -1 is not greater and not equal to 0. Condition is getting failed. So for loop is getting stop executing. Okay, it is stop executing. Okay, after completion of this execution, it is returned back to the same function call of display. Same function call of display here. Okay, but after that break is there, it is getting outside of the switch because of the break. Okay, again green line is there, while of 1, while of 1. Now I am going to select the choice number 4, choice number 4. So through the switch case, choice case number 4 is exit 0. Whenever the compiler reading this particular line, then automatically it is going to be breaking the while. It is going to be breaking the while. Okay, so I said while of 1 is always true, and it is going to be executing again and again. Okay, without getting stop. Okay, maybe if you want to stop the while loop, we are going to be execute the exit line. Exit line. Okay, so this particular programming line will stop the while loop. This particular exit 0 will stop the while loop. Maybe you have the doubt. Why we need to be keep the while of 1? Why need to be keep the while of 1? If without while of 1, if I am running the program, it is going to displaying the menu 1, push 2, pop 3, display 4, exit. I am simply entering the 1. Then it will ask the enter the element to insert. I am going to enter some element. It is canned and it is called the void push value. It is going to be called the function called void push value. So according to the function definition, it is inserted inside the stack. After that there is a break. It is getting outside of the switch case. Then there is no while loop, means then automatically program is getting stopped. Okay, I'll explain in a short way why while of I. If you are not using, we can able to do only one operation once. Only one operation once. Maybe if you want to insert, you can insert one element. Not possible to insert the second one, or not possible to delete the already inserted elements. Okay, so that's why we are going to be using the while of 1 to do the number of time push and number of time pop, number of time display. Okay, so repeating of this particular body through the while of 1 for performing the different operation in a number of times. Okay, I think it is clear. Then application of the stack. Application of the stack. Reversing a string. Reversing a string. If you want to reverse the string, already I said the example. If you are inserting the element in a B, C, D, then if you want to delete the element in a reverse order only, D, C, A, D, C, B, A. Okay, so that is the reversing a string. And this particular stack application is using to evaluate the expression, arithmetic expressions. Okay, arithmetic expression means it is contain the combination of operator and operands. Operators and operands. Okay, that is evaluated by the stack only. And apart from that, we can able to convert from the one form or one notation into the another form of notations. Example, different notation types are infix, prefix, postfix. Okay, if you want to convert, we can use the stack application. Then fourth one, backtracking. Backtracking also done with the help of stack application. Done with the help of stack application. Similarly, there is a number of applications are done through the stack data structure. Okay, okay, that's it. If you have any doubts, you can place the queries in the command box. I'll get back to you through the command itself. Thank you. Thank you for watching.